Thanks, Fernando. Thanks for the introduction. Dear ladies and gentlemen, I'm very pleased to present today a new methodology that we developed for the Science-Based Targets Initiative. It's a new methodology that corporate clients can use to align their greenhouse gas reduction targets with climate science. In the coming 30 minutes, I will explain this new methodology, and then Carol Tornay will present the initiative, and afterwards we are open to have your questions. First of all, I'd like to explain why this methodology was developed and why it's so important. Well, as you all know, greenhouse gas emissions accelerated over time, despite reduction efforts. And most emissions arise from fossil fuel combustion and industrial processes. Here you see a graph taken from IPCC that shows the development of the greenhouse gas emissions globally over time from 1970 to 2010. And what you see in this graph is that emissions almost doubled over time, over these 40 years. It's an increase from 27 gigatons of CO2 equivalent per year to 49 gigatons of CO2 equivalent per year. So it almost doubled in 40 years. Actually, what is even shocking is that the rate of the increase also increased. If you look at the increase per year from 1970 to 2000, the average increase was 1.3% per year of the global emissions. But actually, the last 10 years, emissions grew by 2.2% each year. So it even accelerated. And 80% of this increase was due to CO2 emissions from fossil fuel and industrial processes. IPCC concluded that without additional efforts to reduce global emissions beyond those in place today, emissions are expected to grow further. Main drivers they see are growth in global population and economic activity. And if you look at this chart, you can distill that companies are responsible for a large share of global emissions. If you look at the inner circle, you see how the 49 gigatons of CO2 are split over the economic sectors. And if you look at the pull out, you see the split of electricity and heat production per sector. If you account the electricity and heat production to the sector itself, then industry is accountable for 31% of global emissions. Buildings are responsible for 90%. And also in the other sectors, like in transport, like in the agriculture, forestry, and land use, or FOLU, companies have a big share of those emissions. We estimated that on a global level, companies are responsible for over 60% of global emissions. And without more mitigation actions, we'll probably end up with an increase of global temperature between 4 and 5 Celsius over this century. That was estimated by IPCC in their latest reports. This graph shows you the scenarios that have been assessed by IPCC in their 5th assessment reports. And you see the gray bar with all scenarios that are in that range, and those scenarios are the scenarios that are without any additional efforts. They assessed these scenarios, and these scenarios lead to this temperature rise of 3.7 to 4.8 degrees Celsius to be precise. When you look at the other scenarios being assessed, then the scenarios that can be characterized as scenarios that lead to a temperature increase less than 2 degrees are linked to 450 ppm of CO2 equivalent concentrations. And those are the scenarios with the light blue marked scenarios. And actually those scenarios lead to temperature increase less than 2 degrees Celsius. And the RCP 2.6, the representative concentration pathway 2.6, is one of the latest scenarios created by IPCC. That is the market scenario that was used also for creating our methodology. And that scenario also indicates that when we want to stick to a temperature rise of max 2 degrees Celsius, the carbon budget that we still have is about 1,000 gigatons of CO2 from 2011 onwards. Taking on average the 50 gigatons of CO2 we emit annually, we have about 20 years left for this carbon budget, this global carbon budget of 1,000 gigatons. So it's really important to take actions on the short term. But the main question is, how can these concentration pathways, these scenarios, 2 degree scenarios, be linked, be correlated to the corporate sectors and to corporate accounting and setting targets? And how can you translate this budget of 1,000 gigatons to company level? Well, as you probably also know, the greenhouse gas protocol is applied by many companies. It's the leading protocol to account emissions on a corporate level. And many companies account and report on these emissions using these scopes. Scope 1 is the direct emissions, on-site emissions from the facilities and the company vehicles. Scope 2 emissions are the emissions which are indirect, linked to the company based on the purchasing of electricity, steam, heating, cooling. And Scope 3 emissions are the indirect emissions in 15 categories upstream of the upstream and downstream activities of companies. But how to link a carbon budget to a company who accounts and reports by using these categories? Well, actually there were already 2 methodologies in place, and they can be characterized based on the allocation mechanism. One way to allocate is do it on an absolute way, to look at the pathway, the global 2 degree pathway, or on an OECD or non-OECD level, and allocate the same absolute reduction to each company. So apply the same percentage of reduction to each company. Some companies already set science-based targets based on this principle, but some also use a more linear approach where they say, well, if you look at the long-term target 2050, that's the goal we want. We want this reduction of 60%. They divided this by a linear approach and ended up with 1.5% each year. Other allocation methods look also at economic activity, so they use an intensity indicator and correlate the pathway, the global pathway, 2 degree pathway, with the GDP growth. As you take GDP growth, GDP in most of the scenarios, GDP grows by on average 3.5%, leading to over time to a 350% increase of economic activity of GDP. On a company level, GDP contribution can be accounted for, can be defined as added value, which can be defined as well as gross profit. So taking the emission pathway on a global level, relating that to the GDP growth, you can index that to carbon intensity, greenhouse gas intensity of the CO2 equivalent, gigatons of CO2 equivalents per GDP contribution, as said on company level that can be added value or gross profit. If you use this metrics, then you can apply the global or on an OECD or non-OECD intensity reduction to each company. So in 2020, for instance, you can apply this percentage of a reduction compared to the base year 2010. You can use that percentage reduction and apply that to your company as well. Those two methods were in place already, and we looked at them carefully before when we started creating a new methodology, because the main limitations of these methodologies is that they don't take sectoral differences into account. And as we know that sectors differ in mitigation potential, but also differ in growth, we decided to develop a new methodology, and we were commissioned by CDP, WRI and WWF to develop this. And the methodology was called the Sectoral Decarbonization Approach, and over the past year we developed this methodology. The methodology was based on the 2-degree scenario of IEA, the International Energy Agency, as part of their, and the 2-degree scenario, the 2DS, is part of their energy technology perspective. And this scenario of IEA is very well in line with the RCP 2.6, the latest market scenario of IPCC, which is the 2-degree scenario of IPCC, you could say. We developed this scenario through an intensive stakeholder process, and it's now freely available, and recently it was also published in Nature Climate Change. The SDA methodology is based on a sectoral approach, as said. We have taken the work of IPCC, which I've shown you, and come to the global carbon budget of about 1,000 gigatons of CO2. And that 1,000 gigatons of CO2 can be allocated to sectors based on sector-specific scenarios. So from a sectoral scenario, we have taken the carbon budget, and IEA in their energy technology perspective has modeled several sectors in detail, especially the having emitting sectors. I will show you later on which sectors are included in the work of IEA and were used in creating our methodology. IEA also freely the data of IEA is also available, public available, and IEA has data on sectoral activity, but also electricity use per sector, and also the emissions, of course, the emission pathway per sector. So we have taken that data from IEA, and based on that data we could construct sectoral intensity pathways, both for the direct emissions of sectors, so the scope 1 emissions, but also the scope 2 emissions of sectors, so the emissions related to the electricity use in sectors. The combination of this data gave eventually sectoral pathways, intensity pathways, for both scope 1 and scope 2, direct emissions and indirect emissions of electricity. Combining that with company information, we come up with targets for companies. I will show you later on how the methodology works. With the work of IEA, we were able to cover about 60% of global GHG emissions. The International Energy Agency especially focuses on energy use and CO2 emissions from industrial processes. So it doesn't include non-CO2 emissions. It's mainly energy related and process CO2 emissions. But with the scenario of IEA and the data, we could cover a lot of the global emissions already. So electricity is covered, the whole industry sector is covered. Transport is covered, all transport types, and also buildings, residential buildings we excluded because that's not immediately related to corporate emissions, but all commercial and service buildings are included in the methodology. What we could not include yet was other energy, which is mainly related to fossil fuel extraction and production, and that is not included, and there's also a large share of non-CO2 emissions in this sector, and that's not modeled by IEA. Also agriculture, forestry and land use, AFOLU is not included. Also there a lot of emissions are non-CO2 emissions. However, on this last sector we are currently developing a new methodology with the University of Aberdeen and PBL, looking at 10 major agricultural and forestry commodities. If you look at the 2-degree scenario, the 2DS of IEA, taking the emission pathway per sector, we assess the total budget of IEA is from 2010 to 2050 is about 1,054 gigatons of CO2. It's well in line with the scenarios of IPCC and also with the RCP 2.6. With the data of IEA, we were able to distinguish between 13 sectors, which are all indicated here. So it's power, it's for the heavy industry, it's cement, iron, steel, aluminium, chemicals and petrochemicals, pulp and paper, and the remaining part of industry, we call that other industry. So there's a remaining element, which is other industry. For the transport, we have all types of passenger transport included in the methodology, and the remaining one, which is also mainly freight transport, is within other transport. Actually, recently we also received data on freight transport, more detailed data on freight transport, and we are currently working on elaborating pathways as well, like for passenger transport, for freight transport. And as said, we included service commercial buildings into the methodology as well. Next to the emissions, we also took the activity data from IEA, and some sectors we have physical activity indicators, like for the power generation we have megawatt hours, and for many of the industries we have ton of product. But for some sectors which are more homogeneous, there is not a clear physical indicator that describes the emissions or is correlated to the sector or the emissions of the sector. So in that case, we fall back to the economic allocation, which I explained to you as well, and that's the contribution to GDP, and on a company level, that's value added. For passenger, it's of course passenger kilometers, and for buildings, it's square meters. So all this data we used in the methodology as the activity data to come up with the intensity pathways, CO2 per ton of steel or per ton of product, or CO2 per emissions per megawatt hour. In the methodology, we distinguish between two types of sectors. We have homogeneous sectors, which can be described with a physical indicator, and we have heterogeneous sectors, which are based on the economic allocation. The homogeneous sectors, and that's a new element we included in the methodology. We assume that the intensity of companies in the homogeneous sectors converge to the same level in 2050, and that's an important assumption, because that defines the pathway per company. I will explain you in the next slide also how it works in more detail. But the main assumption is that carbon intensity of companies converge to the same level in 2050. For homogeneous for heterogeneous, we have the methodology that we apply, the absolute pathway. So each company in a heterogeneous sector gets the same reduction percentage as the sector, because this was eventually decided in the draft version of the methodology. We had intensity reduction, but we couldn't guarantee that it would stay within the global budget. So we decided in large discussions with the NGO to go for the absolute emission allocation, you could say. And each company in the sector gets the same absolute emission reduction as the sector. In this way, we could guarantee that the method stays within the carbon budget. And for this heterogeneous sectors, we already apply a sectoral pathway. So the emissions pathway is on sector level, and it's also two pathways for scope 1 and scope 2. So there's a different pathway for scope 1 and scope 2. The main asset, the main key feature of the methodology is for the homogeneous sector, where we have the assumption of the convergence. And how does it work? Well, based on the data of IEA, we were able to construct a sectoral pathway, so the emissions per ton of product over time, or the emissions per megawatt hour, or the emissions per square meter from 2010 to 2050. Some companies have the starting point in 2010, a higher carbon intensity, taking the same market share. So if their market share doesn't change over time, and the market share is their activity correlated with projections of IEA, if that doesn't change, then this is the pathway to converge into 2050 levels. But actually, when the market share changes over time, if the company predicts a very high growth and a growth which is larger than the sector growth predicted by IEA, in the methodology, the company gets more strict targets. So fast-growing companies should do more. That's the main message that the methodology gives. When there is a decrease in market share, there's less strict targets. Same principle accounts also for companies with a lower carbon intensity. Since they are lower, of course, the targets are less strict towards 2050, and also the growth or decrease in market share is taken into account in creating the pathway. And actually, these pathways, these lines are the targets, pathways for a company. So actually, when a company wants to set a target in 2030, then with the same market share, then this dot, you could say, is the target for that company in that specific target year. Well, as said, this methodology was created over the past year. We have already applied this methodology to over 20 multinational companies in various sectors, ranging from ICT to consumer goods like apparel, but also in the heavy industry, like the chemical sector, like the cement sector. Consumer brands are interested to apply the methodology. However, also heavy emitting companies are getting more and more interested in this methodology, but they of course want to know more about how the scenario was modeled, which technologies were taken into account in the scenario. And also recently, World Business Council for Sustainable Development started up initiatives to get more insight with companies, with IEA, into these scenarios. But as said, we already applied the method to some heavy emitting companies as well. The methodology is well received, and the outcome is very valuable for companies and provides a lot of information for their target setting process. However, for heterogeneous sectors like the chemical and petrochemicals, but also other industry, the methodology needs further refinements over the coming years. And to do that, we propose that more 2-degree scenarios are being developed and data from these scenarios are publicly available to be used in creating methodologies like this. To give you some more insights into the methodology, I created this fictional example of a beverage company with emissions scope 1, scope 2, and scope 3. I will mainly focus as an example on the scope 1 and 2 emissions and on the scope 3 purchased paper. This is a fictional company, beverage company with 84 million gross profit in a base year, and it produces 1.1 billion juice packs and purchases paper about 50,000 tons. The prediction is that they grow with 3% each year, and they want to assess with our methodology the SDA target for 2020. As said, the methodology is freely available, and we also created a tool with the methodology, and the tool is publicly free available on the website of the initiative. What is important to start actually before entering the data into the tool is to have the right allocation of the company's activities to the sectors. For this beverage company, if you look at how to correlate the company's activities and emissions to the sectors, then this is the best allocation. Scope 1 emissions of operations, of the operational process, should be linked to other industry, which can be also measured as an activity indicator with value added. Scope 2 emissions from operations also is linked to other industry because we have scope 1 and 2 in the method per sector. Scope 1 emissions from their own fleet, that depends on the type of transport, but a large share is probably passenger transport, so that can be correlated to the passenger transport. And maybe there's also some freight vehicles there, so that will be allocated to other transport. If you look at scope 3 emissions like logistics and purchased paper, they are allocated to other transport, and pulp and paper also using value added and tons of paper as an indicator. So this is the setup for the allocation of the company's activities to the SDA sectors, and also how the online tool should be used. In the next slide I will show you how scope 1 and scope 2 for operations in the tool works, and how also purchased paper scope 3 emissions work into the tool. Well, in the online tool you can fill in, of course, your company name and your activities, but main element for this is the allocation of the sector. First, I start with choosing the right sector, and as said, the operational processes are linked to other industry. So that sector was marked, and then the second step is to fill in the scope 1 and scope 2 emissions. If that's done, then also the electricity use is asked, and finally the results already come up. Here you see the outcome of the application of the methodology, and as said, for the other industry, the absolute emissions are used as allocation principle. So in this sense, the pathway, absolute pathway of other industry is applied to this company. And here you see the differences between the pathways in scope 1 and scope 2. So you see that scope 1 should be reduced by -80% and scope 3 minus. the outcome for scope 1 and 2 is a different target on scope 1 minus 80% and on scope 2 minus 3%. In total, this leads to a minus 10% reduction in 2020 compared to the base year 2010 for scope 1 and 2 for this company. In the next slide, I will show you how the tool can also be used to set a target on scope 3 for the purchasing of paper for this fictional company. First of all, then you should use the tool by clicking on the paper sector, and then you also need to fill in the activity numbers, so the total ton of paper that you have purchased, and also taking into account the growth, because this is a sector that is a homogeneous sector, so also the activity is important to take into account. So it asks for the activity in the base year, but also the activity in the target year. Next to that, it requires also the emissions, of course, to put in, and then it provides the final outcome. And here you can see the final results. Here you see the tons I indicated in the beginning. 50,000 tons of paper was purchased in 2010. And here you see that expected is that 61,500 tons of paper are purchased in 2020. This leads to a total reduction of minus 40% absolute, but on an intensity level, you could say that it accounts for minus 30%. And especially when purchasing, for instance, materials like paper or ton of or steel or aluminium, this intensity indicator is very valuable to have, also to use in the purchasing of materials. In this case, in the base year, the carbon intensity of the purchased paper was 1.24 tons of CO2 per ton of paper, and it should go down by 30% to 0.87 tons of CO2 per ton of paper. So these is an example how the methodology can be applied to the scope 1 and 2, and also to scope 2 purchasing of paper. And here you see also the results graphically shown, where you see clearly the convergence principle of the intensity for the paper. I'd like to finalize my presentation of the SDA methodology with the key characteristics. The methodology was based on the best of science. It's used the SDA used the IEA modeling in their energy technology perspective. It created sectoral intensity pathways, and targets can be set on an intensity level or an absolute level. It distinguished between scope 1 and scope 2, which is also new when you compare that to existing methodologies, and also targets can be set on scope 3, especially for the sectors that are covered in the methodology. The methodology is flexible to set targets up to 2050, and also that's a big advantage of the methodology, because also the long-term targets are really important for companies to set. And the methodology will be improved over time, given new insights from climate science, but also given that new scenarios on sectoral level will be developed over time, and of course we like to update the methodology, taking these new information, new insights into account. If you have any questions beyond this webinar, you can always reach me, and the contact details are in this slide deck. Carol?
Yes, thank you very much, Giel, for your presentation, and welcome everybody from my side as well. After Giel has presented or given you an overview of the Sectoral Decarbonization Approach method, I will talk a little bit more about the Science-Based Targets Initiative. And we will be able, or we will have some time at the end of my slides to discuss questions about Giel's presentation and also about my slides. So first of all, a short introduction about the initiative. So there are 4 organizations working on the Science-Based Targets Initiative, CDP on the one hand, the UN Global Compact, World Resources Institute, and WWF. And the main objective of the Science-Based Targets Initiative is to raise the ambition level of corporate greenhouse gas target setting and align it with a 2-degree decarbonization pathway. We have started working on this initiative a couple of months ago and have already launched or presented a couple of reports. So on the one hand, we have a work stream that is intended to facilitate the adoption of science-based emission reduction targets. Giel has already talked about the method, the Sectoral Decarbonization Approach, and the online tool, of which you have seen an example in Giel's slides. Besides those 2 things that we have already developed, we have started the public consultation of the target setting manual last week. The target setting manual is intended to give companies an overview of science-based target setting in general. So it includes a chapter about the business case, how to set a target, the different methodological approaches that exist, etc. And I would like to invite all of you to have a look at the draft manual. It's available on the Science-Based Targets website, and to also give comments, because now we go through a public consultation and then we will revise the manual again before we publish the final version. Besides that, we have another work stream which intends to incentivize the adoption of science-based emission reduction targets. Back in May, during the Business and Climate Summit in Paris, CDP has published the so-called Mind the Science report, which looks at 70 companies and looks at the historical emissions of those companies and also how ambitious their targets are at the moment. We are currently working on developing an online platform to track and also score companies' targets. And the platform is expected to be launched towards the end of the year, so at COP21. And besides that, we are actively working with companies to get them to commit to develop a science-based target, and this campaign is called the Call to Action campaign, and I will talk a little bit more about that in my next slides. So the Call to Action campaign is basically asking companies to demonstrate leadership and align their targets with climate science. And we have an ambitious goal. We plan to get 100 companies that commit to develop a science-based target by the end of this year, and then 250 companies that have a science-based target by 2020. On the next slide, you see the process that a company has to follow in order to join the initiative and the call to action. The first step is to complete the commitment letter, and this first step is just a commitment to develop a target. So the company does not necessarily need to have a target in place yet, because we know that it takes some time to develop a target, to do all the analysis, and especially as well to get internal buy-in and everything. So the first step is mainly a letter of intent. It could be called that way as well. Then a company gets up to 24 months after making the commitment to develop the actual target. Once the target has been set, a company is asked to submit the target to the Science Based Initiative by completing a form that includes detailed information about the target. The technical team of the initiative will then perform a quality check of the target to make sure that the target is in line with the eligibility criteria. And then the last step is about announcing the target. And there are several possibilities. It depends as well on the company and where the company actually stands. But the company will get listed on the Science Based Targets website and on other websites as well. And there are possibilities to do other communication things. Just one quick comment about the eligibility criteria. I don't go into detail about that because I would like to use the time we have left to also answer some questions. But please go to the Science Based Targets website and have a look at the eligibility criteria. They're mainly about, which time frame a target needs to cover, which scopes a target needs to cover, etc. And if you have any additional questions, please don't hesitate to contact us. So this was very quick overview about the overall initiative. If you would like to get more information, have a look at the website. We have a lot of material online as well, videos about past webinars we have held, etc. In the download section. So this was it from my side, and I think now we have some